Hello, today I'll be coding a neon tile snake, and if that doesn't tell you anything, then keep on watching and you'll see what it's about. So we're going to start with a 3D assembly, and within it we're going to have a number of tiles. So let's say 10 tiles, 10 times, and here we're going to have tile elements, and these are 3D shapes, so 3D shapes. And for every tile, we're going to have triangular tiles. So we're going to have 3 lateral faces and 2 triangular base faces. So that's 5 faces in total. 5 times. Oh, sorry. Okay, this is it for the structure. Now let's move on to the styling. And we're going to have tile face. And these are going to have some dimensions initially, and we're going to set a width and a height. So the width is going to be the base edge length, the edge length of the triangular base. Let's set it to 10 ems, and let's set the height of the tile to 1 em, because we like nice round numbers. So here we have width, base edge length, and the height is height, as before. So now we're going to set a background, and now we can see them, and let's highlight them a bit. We're going to set a box shadow, which is going to be inset, 0 for the offsets, 0 for the blur, and we're going to set something for the spread, and current color. And now we can see the individual ones. Now, one more thing I'm going to want to do here, I'm going to have a relative highlight, and this is going to be something like this. And I'm going to have the actual highlight is going to be the relative one times the base edge length. So here I'm going to use that highlight. Okay, now we're going to need to compute a number of things. We have 3 vertices for the base faces. 3 vertices, 3 edges. And for the base face, for each edge, we're going to have a base angle, a base central angle corresponding to it. So this is going to be 360 degrees over the number of edges, which is equal to the number of vertices. And then we're going to compute the circumradius for these triangular base faces. And that's going to be half the edge length, which is base L, over sine of half that base central angle. Okay, now that we have this, we can reset the dimensions, the width and the height for the base faces. So these are the settings for the lateral ones, and we set these as the defaults because we have more lateral faces than base faces. And now we're going to have nth child. So after the lateral faces, we have the base faces. So it's going to be n plus the number of lateral faces, which is equal to the number of edges of the base face. So here we're going to set a new width. And the same height. And we haven't computed this diameter yet, but it's twice the radius. Okay, so now we have all of these. However, we don't want these base faces to be square. We want them to be triangular. So we're going to have a mix-in here. So mix-in regular polygon. And this takes the number of vertices, which is equal to the number of edges. And by default is that value. And then we're going to have the circumradius, which by default is going to be 50%. And then here we're going to have an empty list of points. And we're also going to compute a base central angle, which is 360 degrees over n. And now we're going to have a loop to populate that list from 0 to n. and we compute the current angle, which is the index times the base central angle. And then we compute the x and y coordinates. And we're going to use calc here because we want this circumradius to be able to be something else than a percent value. We might want it to be an m value. So here we have 50% because everything is relative to the central point, the 50% point. And we add up the circumradius times cosine of the current angle. And we're going to have pretty much the same for the y coordinate, except this is going to be y, and here we're going to have sine instead of cosine. And now we add to the list of points. So we have its previous version and these x and y coordinates. Now, finally, last thing we're going to do after this loop is set a clip path polygon, and we're going to use that list of points. Now we're going to take this regular polygon mixin and we're going to include it here. So now we have triangles, but we want them to point up, which is why we're going to offset this current angle. So we want to go from 3 o'clock to 12 o'clock. That's going by minus 90 degrees. So we're going to have an offset angle, and in this case the offset is going to be minus 90 degrees. So here, for each current angle, we're going to add the offset angle. And now all these triangles point up. However, you see these lateral faces are highlighted. This triangle isn't. So let's add that sort of highlight, and we're going to add it with a pseudo element using the zero width tunnel method. And the link to the article which explains this is going to be in the description below. So we're going to use a pseudo element. And let's modify this mixin to do that, have that inside clip. We're going to have a highlight, which by default is going to be 0. And we're also going to have a second list of points, an inner list of points. So that cuts the inside. And then we're going to have a different maximum, which is going to be n plus. And this is going to depend on the highlight. If it's greater than 0, we add 1. Otherwise, it's just 0. So it's going to be also n. So we're going to loop up to m. And one more thing we're going to compute is a second radius. And this one is going to be 1 minus the highlight. Actually, this is going to be a relative highlight of sorts times the circumradius. So now we're going to take all of this and we're going to copy if the highlight is greater than 0, then we're going to have all of this, and we're going to modify this to use it for the inner. So we go the opposite way, so it's going to be minus I times the base angle. Here we're going to use the second radius, and of course we're going to take the inner list. Now after the loop, what we're going to do is join these lists. So points is going to be a join points and inner. So let's collapse this, and what we're going to do here is div after position absolute, and here we're going to have after, and it's going to have, let's say, width inherit, height inherit, background current color, content nothing. Okay, and now we're going to include this with a few slight changes. So we're also going to use the same number of vertices, also 50% for this, except the highlight is going to be twice the highlight over the circumradius. So this should do it, and it does. As you can see, it works nicely. Now, something else we're going to do is we're going to have the assembly. We're going to put it right in the middle. Top 50%, left 50%. And something else we're going to do here, let's collapse this after, we're not going to need it after. We're going to have margin minus, and here we're going to have a different margin based on the dimensions. So a margin is going to be minus half the height, and then we're going to have minus half the width, which is going to be that base L. And we have those parentheses because otherwise SAS would just perform the subtraction. So now that we have all the faces in the middle, we can set some transforms on them so that we can make everything in 3D. But first, we're going to have an animation here. So animation, rotation, and it's going to have a random duration, something like this. Linear, infinite. And let's set a delay, let's say minus 6 seconds. And we're also going to have animation play state paused. Now let's set this animation. So we're going to have keyframes, to something random, rotate X, 1 turn, and change with a rotate Y, 2 turns. Okay, so this should position the whole thing a bit differently. Should have done it. It doesn't do anything. Wait. If I don't. Okay. Oh, I forgot to set the rotation there. Sorry. Now this should work. So, and if I do this. Okay, now let's set a transform here. Transform, we're going to have rotate 3D. And the x component of the vector of the rotation axis is going to be I. And this is going to be 0 by default. For the y component, it's going to be j, and this is going to be 1 by default. For the z component, it's always going to be 0. And then we're going to have another custom property for the angle, which is going to be 0 degrees always. And then we're going to have a translate z, which by default is going to be the in radius, which I just now noticed that I haven't computed. So I'm going to compute it, and it's going to be pretty much the same as this, except I'm going to make a few minor tweaks. Of course, the name, and here I'm going to have tangent instead of sine. So now that I've computed the in radius, here I'm actually going to have a custom property, and I'm going to have z, and of course here I'm going to start resetting stuff. So I'm going to have I is 1, j is 0, the angle A is 90 degrees, and that z value is half the height. So half the height. And now for the other two lateral faces, for the second and the third lateral face, we're going to have a loop here. So for I from 1 to, sorry, we're not going to set things again for the first one. That's why we started from 1 and not from 0, because the defaults are good enough for the first one. So here we're going to have A is I times the base angle. So this should do it. And it looks like it does. Now the thing is, here I have everything flattened into the plane of the parent. So I'm going to have class So for all 3D things, I'm going to have to set transform style, preserve 3D. So this is for all 3D things. Nth child, sorry. So this does it, but as you can see, all base faces are set on the bottom there. So we want to bring one to the top. And what we're going to do is last child, and here we're going to have this A value minus 90 degrees. But this doesn't seem enough. So one more thing we're going to do, and let's collapse this one as well, because we're not going to need it. We're going to add a final transform to the chain. So this is going to be nothing by default. But here we're going to reset it. And it's going to be rotate half the base angle. Okay, now I can collapse this as well. And now I can start distributing the tiles. I'm going to have n tiles is 10, just like in the structure. And I'm going to compute a few things here. The distribution angle. This is going to be 360 degrees over the number of tiles. And then I'm going to have a distribution radius. And this one is going to be half the height over sine of half this distribution angle plus the circumradius of a base face of a tile. So now that I have this, I'm going to set a transform. I can collapse this. And here for the tile, I can set a transform. And this is going to be rotate. And here I'm going to have an AZ angle, which is 0 degrees by default. And then I'm going to have translate. And this is going to be the distribution radius. Now I'm going to loop through the tiles for I from 1. And again, I don't reset these values for the first one because the defaults are good enough. To the number of tiles. Nth child. I plus 1. And here I'm going to have AZ is I times the distribution angle. And I have the tiles distributed now. Now I can start rotating them. And actually I can add like more complex transforms on them. So let's see. We're going to have a precision for the keyframes. And we're going to have a base percentage. So this is going to be 100% over the precision. And then we're also going to have a keyframe angle. And this is going to be 360 degrees over the precision. And we're also going to have a keyframe radius. And this one, let's say, is going to be 0.75 times the distribution radius. So this should do it. And one more thing we're going to set here is an animation duration. Let's say 7 seconds. I don't really like to set very random values for this. And often stuff like prime numbers. So yeah, here I'm going to have keyframes, animation, and I'm going to have a loop for I from 0 all the way through k, and I'm going to compute a current angle, which is I times the keyframe angle, the base angle. And now for the keyframes, I'm going to have I times the base percentage. And here I'm going to have a transform, which is going to be a base value. And then I'm going to have a translate 3D. And here I'm going to have the keyframe radius times cosine of the current angle. Then we're going to have 0 along the y-axis. Then we're going to have the keyframe radius times sine of the current angle. So yeah, this is for the translate. Then we're going to have a rotate y, and this is going to be twice the current angle. And then we're going to have a scale, but we want this. What's wrong? 4. Sorry. Okay. We're going to want to have to simplify things. So we're going to have function. I don't want to write that scaling factor 3 times. So that's the whole purpose of this. The scaling factor, sorry, f. And this returns scale 3D f, f, f. So that's the whole thing. I don't want to write that thing 3 times. So here I'm going to have, and the scaling factor is going to be the absolute of I minus half of k precision over k plus 0.5. So yeah, this should do it. And now here I'm going to make this the base, and then I'm going to have animation. This is going to be that on t is in out infinite. So this should do it. Okay, now I'm going to have an animation delay. So this is going to be minus I times t over the number of tiles. Okay, now I'm going to want one more animation here, and this is going to be a highlighting animation. So I'm going to set a different duration here. This is going to be 1 second. And to show you what I mean by highlight, let's say we have a filter here. So filter, grayscale, let's say something like 0.8. And now let's say we have contrast, something like 0.2. And now let's say we have brightness, something like 0.2 as well. Okay, now let's say we have here color blue. Okay, now let's take this out of here, and we're going to put it in an animation, in a highlight animation. So we're going to have keyframes, highlight, and this is going to be 0%, 70%, and we're going to have that filter. And here we're going to have animation, and it's going to be highlight, the highlight animation duration, ease in out, infinite, and alternate. And now that I've done this, I'm going to take this animation delay from here, and I'm going to modify it for the tile. So I'm going to have, this is going to be twice, because it's an alternating animation, and it's for the highlighting one. And something else I can do here is increase this number to something like, let's go higher up, 50. And as you can see, that looks a lot crazier now. Now, one more thing I want to be setting here, body and height, 100 viewport height units, perspective 25 ms, and background, this is going to be a dark gray something, and one more thing here, overflow hidden, And now that I've done this, a couple more changes here. So here I'm going to want to have font size depending on the minimum viewport dimension. So let's say 1.5 viewport minimum. And here I want to get rid of this. And this is pretty much the result I've been after. This is it for today. You can find a link to the CodePen demo in the description below. And if you have any questions, you can drop them in the comments or send them on Twitter. I hope you've enjoyed this video, and if you have and you want me to be able to do more of this in the future, please consider supporting my work in one of the ways explained in the description below, with a donation by getting me something off my Amazon wishlist, or at least by sharing this to show the world what can be done with CSS these days, because I think it's pretty cool. In any event, thanks for watching.